This video is about demonstrating the knowledge of a parallelogram, triangle, trapezoid, rhombus, kite, circle, and regular polygon, and solving word problems and applications using area of figures. So in number one, we want to find the area of the figure. If we look at this figure, it is a parallelogram, and a parallelogram area is equal to base times height. So remember that in a parallelogram, your opposite sides are congruent. So if the top side is 23, the bottom side is going to have that full length of 23 as well, which is going to be our base. Our height is this dotted line that we don't know yet. So if the whole base is 23, we can subtract 17 to get 6. And we know the opposite sides are congruent, so this is 10. So we can use our right triangle over here to find the height, which we'll call h. So when we set up Pythagorean theorem, we have 10 squared equals 6 squared plus h squared. So we get 100 equals 36 plus h squared. H squared equals 64, so h is 8. So we now know that we have a height of 8 and a base of 23. So we go to find our area. Our area is going to be equal to 23 times 8, which is going to get us 184 centimeters squared. In number two, we have a trapezoid. To find the area of a trapezoid, our area is equal to 1/2 base 1 plus base 2 times the height. So if we're looking at this trapezoid, we know the bases are 4 and 22. We can draw in a dotted line to create the heights in our trapezoid. So this is going to create a rectangle and two triangles. So if we bring the smaller base down 4, out of the 22 units, we have used 4 so far, which means there's 18 left over, which is going to evenly be split between the two triangles, so 9 and 9. Then we can focus on one of those triangles to use Pythagorean theorem to again find the height of our trapezoid. So we would have 15 squared equals 9 squared plus h squared. 225 equals 81 plus h squared. H squared is equal to 144, so h is 12. So we now have our bases and our heights. So our area is going to equal 1/2 base 1 plus base 2, so 4 plus 22 times the height of 12. So our area is equal to 1/2 of 26 times 12. So we get our area is 156 meters squared. In number three, we want to find the area of the figure. This figure is a rhombus. So to find the area of a rhombus, our area is equal to 1/2 diagonal 1 times diagonal 2. Remember that in a rhombus, your diagonals are bisected. So that means we have 2 parts that are 14 and 2 parts that are 10. So when we go to find the diagonal, we need to add both numbers on that line. So our diagonals are going to be 14 plus 14, which is 28, and 10 plus 10, which is 20. So we would have 1/2 times 28 times 20. So our area is going to be 280 meters squared. In number four, we have a hexagon with a perimeter of 108 inches. Find the area of the hexagon. So our area of a hexagon is equal to 1/2 apothem times perimeter. So we already know the perimeter is 108. If the perimeter is 108, we can divide by 6 sides to get that our side length is 18. So when we draw in our apothem and we create that 30, 60, 90 triangle, the side is divided into 9 and 9, so our S is 9. Which means our apothem, the S root 3 side, is 9 root 3. So our area is going to equal 1/2 9 root 3 times 108. So when we multiply, we get the area is 486 root 3 inches squared. In number four, what is the perimeter of a square that has an area of 100 feet squared? So remember, in a square, you have 4 congruent sides. So right now we know that our base and our height are x. So the area is equal to base times height. So we would have 100 equals x times x. So 100 equals x squared, which means x is 10. So all the sides of our square are 10. So to get the perimeter, we have 4 sides with a length of 10. So our perimeter is 40 feet. In number 6, find the area of the area of a kite is 48 yards squared. If the length of one diagonal is 16 yards, find the length of the second diagonal. So our area is equal to 1/2 diagonal 1 times diagonal 2. In this case, we already know that our area is 48 and that one of our diagonals is 16. So when we substitute in, we get 48 equals 1/2 of 16 times the other diagonal. Half of 16 is 8, so 48 equals 8 times the diagonal. So our other diagonal is 6 yards. In number 7, the area of a trapezoid is 60 centimeters squared. If the height of the trapezoid is 6 centimeters and one of the bases is 8 centimeters, what is the length of the other base? So our area of a trapezoid is equal to 1/2 base 1 plus base 2 times the height. We know that the area is 60. We know that the height is 6. And we know that one of the bases is 8. So when we substitute that in, we get 60 equals 1/2 base 1, which is 8, plus our second base times the height of 6. So we can multiply 1/2 times 6 is 3. 60 equals 3 times 8 plus b. We can distribute the 3, so 60 equals 24 plus 3b. Subtract 24, so 36 equals 3b. When we divide, b is 12, so 12 centimeters. In number 8, an isosceles triangle has legs with a length of 50 feet and a base of 60 feet. What is the area of the triangle? So in an isosceles triangle, we have 2 legs that are congruent at 50 and 50, and we have a base of 30. When we draw in the height, we have a base of 60. When we have draw in the height, we split into 30 and 30. So we can use one of those triangles with Pythagorean theorem. So we would have 50 squared equals 30 squared plus h squared. 2,500 equals 900 plus h squared. 1,600 equals h squared. So h is 40. Now that we know the height is 40 and the base is 60, to get the area of a triangle, it is 1/2 base times height. So our base is 60, our height is 40. 1/2 of 60 times 40. And that's going to get us 1,200 feet squared. In number 10, the area of a rhombus is 312 millimeters squared. If the length of one diagonal is 24 millimeters, what is the length of the other diagonal? So to find the area of the rhombus, it is 1/2 diagonal 1 times diagonal 2. We know the area is 312. We know one diagonal is 24, so we want the other diagonal length. So we have 312 is equal to 1/2 times 24 times d. So 312 equals 12d. When we divide, 312 divided by 12, we get 26. So our other diagonal is 26 millimeters. Last, we're going to have composite figures and shaded regions. So composite figures are where we put multiple shapes together. So in number 11, we have 2 shapes here. We have the area of the triangle plus the area of the rectangle. So the area of a triangle is 1/2 base times height. If the base of this side is 24, the base of our triangle is also 24. So when we draw in the height, it splits that into 12 and 12, so we can do Pythagorean theorem to find the height. 15 squared equals 12 squared plus h squared. So we have 225 equals 144 plus h squared. 81 is equal to h squared, so h is 9. So the area of the triangle would be 1/2, the base is 24 times 9. So we get 108. The area of the rectangle is base times height, so our base is 24 and our height is 20. So that's going to get us 480. We add these numbers together, we get 588 feet squared. In number 12, the two shapes that we have are a triangle and a rhombus. So we want the area of the triangle plus the area of the rhombus. So the area of a triangle is 1/2 base times height. The area of a rhombus is 1/2 diagonal 1 times diagonal 2. Now, in the triangle, we need this missing side, so we can use Pythagorean theorem with the 12 and the 5 to find that length. So x squared equals 12 squared plus 5 squared. X squared equals 169, so x is 13. So we would have 1/2 times 7 times 13 for the triangle. So we get 45.5 plus the area of the rhombus is 1/2 diagonal times diagonal. So one diagonal is 12 plus 12, which is 24. The other diagonal is 5 plus 5, which is 10. So we have 0.5 times 24 times 10 is 120. So 120 plus 45 plus 5, 160.5 meters squared. Lastly, we have the area of a shaded region. So a shaded region, instead of adding the shapes, we are going to be subtracting the shapes. So in 13, we would have the area of a circle minus the area of a trapezoid. The area of a circle is pi r squared. So if 20 is the diameter, the radius is 10 and 10, so we have pi 10 squared, which would get us 100 pi, minus the area of a trapezoid, 1/2 base 1 plus base 2 times our height. So we'd have minus 1/2 of 12 plus 20 times 8. So when we multiply, that is 1/2 times 32 times 8 would be minus 128 centimeters squared. They're not going to combine because one has pi and one does not. In 14, we have the area of a square minus the area of 4 circles. So our square is base times height, which is 8 times 8, so we get 64. The circle is 4 times pi r squared. So if I draw two diameters of the circle, that's making the whole length of 8, which means each diameter is 4, which means each radius is 2. So we'd have minus 4 times pi 2 squared. 2 squared is 4 times 4 would get us minus 16 pi meters squared. In 15, we have a square minus the area of a triangle. So our square is base times height, which would be 12 times 12, 144. Our triangle is 1/2 base times height. So our base is 12, and because the triangle is reaching from one side of the square to the other, we know the height's also 12. So we would have 1/2 of 12 times 12, which would be minus 72. These are both numbers, so we can subtract them. So we would get 72 inches squared.